Okay, we talk about the fact that row operations don't affect the span of the row vectors. Why is that? Well, you've got three row vectors here in any one of these matrices. Okay, one of the row operations is you multiply a row by some constant number. Well, multiplying a vector by a constant number doesn't change what it spans. Okay, it's just that if you're going to do a span involving multiples of the three vectors, let's say, whatever vector you can get with a sum of multiples of the three vectors, you can get with a sum of multiples of the three vectors that you have after you've multiplied that vector by the number, because you just have to multiply that vector by a different number to get the same thing you would have before. And I really want you to think about that, so I don't want to be too much more explicit than that. If you interchange two of the vectors, that doesn't change the span of the three vectors. And if you add multiples, a multiple of one vector to another, that doesn't change the span of a set of vectors. And that's really what it comes down to. So none of the row operations change the span. So the rows of this one span the same thing that the rows of this one do. The rows here span the same thing that these rows do, and so forth, all the way down to this vector. And anything else you might get from this matrix, not vector, this matrix by row operations. And it's not difficult to see why that is if you just start writing things out. So, okay, again, big deal. The span of your reduced matrix, of the row vectors of your reduced matrix, is identical to the span of your original matrix. And the vectors, in this case, in the reduced matrix, will be much simpler than the vectors that you had in the original matrix.